I'm Professor Sarah Gilbert of the Jenner Institute at Oxford University, and when I was at school I really loved studying biology. So I want to encourage you to follow whatever you really like studying, whether it's science, technology, engineering, maths, or maybe some other subject. Don't be put off by wondering about whether this is a suitable subject for girls. Scientists are scientists. It doesn't matter whether they're female scientists or male scientists. We're all scientists and we can do a great job. So follow the dreams that you want to follow and good luck with your career.
Hi everybody, I am Sarah Batawi and I am a scientist at the Jenner Institute, University of Oxford. Today I'm going to introduce you to Amazing Antibodies. So, what are antibodies? Antibodies are Y-shaped molecules that are present in our blood, and they are important in protecting us from disease. When we get infected by disease or receive a vaccine, our bodies produces lots of these antibodies. More importantly, our body remembers how to make these antibodies. So in the future, if we encounter the disease again, we can make lots of these antibodies much more quicker, and hopefully this will prevent us from getting the disease. So how do they work? Each antibody has two arms. These arms can stick to a unique part of the disease-causing organism known as antigen. Examples of antigen are the spikes on the surface of viruses, or it could be sugar on the surfaces of bacteria. At any time point, our body can produce lots of different antibodies. Each antibody can recognize the antigen in a slightly different way. Some antibodies prevent the infection of the cells of our body, and some help other cells of the immune system to fight the disease. Over time, the end of the arm could actually get better at its job and can get stronger, which will help it to stick to the antigen more tightly. So where are antibodies found? Antibodies are commonly found in our blood. However, we can still find them in our spit, in our nose, in our gut. Even mom can passes antibodies to the babies grown inside their tummy and provide them in their milk. So how do we study them? We can separate them from the cells of our blood by spinning the blood really fast. This is possible because some parts of the blood are heavy and some are light. Red blood cells are the heaviest, so they sink at the bottom. Next layer has the white blood cells. And finally is a straw-colored liquid, which we call plasma. This has the antibodies. Should I tell you a secret? You can make a similar effect at home by using water, syrup, and oil. Antibodies and plasma can tell us a lot. They can actually tell us if a vaccine has actually worked or you have previously been infected with a disease. All of these are useful for scientists like myself who study the human immune system. Next, I'm going to hand you over to Lizzie, who is going to show you how to make your own origami antibodies at home.
My name is Dr. Lizzie Burns. I'm going to show you how to fold your very own origami antibody, the Y-shaped proteins that your body uses to spot viruses, and they're boosted by vaccines. This is the way that our body helps spot viruses and defend us as well. So you should hopefully have a sheet like this, and I want you to simply cut out that square nice and accurately. Here's one that I've cut out earlier. So I'm going to bring this down and I will show you the steps. So if you start with the picture, turn it over and we're going to fold it in half to make a rectangle. And science requires imagination, focus, persistence, many qualities that we're using here and now. We're going to take the outside to the middle line, lots of creativity as well. So I'm bringing the outside to the middle, do that on both sides, it looks like a little cupboard. Next, I'm going to fold it in half, one end to the other. Again, be accurate, take your time, it's more enjoyable that way too. Opening it up, and next I'm going to bring the outside to the middle, And the good thing is with a film, you can pause, you can go back, have a look, bottom to the middle. That's it. All right, so it should be looking like this, a little multi-layered square. I'm going to tilt it now to one side. I'm going to open up a flap, and I'm going to take one side and I'm going to bring it up to that vertical line in order to add a diagonal line. So, like so. So I'm lining that up, squashing this down, and it's giving that diagonal line. I'm going to do the same on the other side. There we go. Again, you take your time. So it should be looking like that inside, and then squash it down. And in squashing it down, you should also be getting nice points through the ends there. The good thing is with paper, if something's not quite fitting, you can reposition until you're happy. It's looking a bit like a house actually at the moment. There we go. So something like that. And we're going to do the same thing on the other side, opening it up, going through those diagonals. Straight. I recommend the solid surface will make it a little bit easier. And again, squashing it down. So it looks like this rather interesting shape. Next, we're going to make it look like a windmill. So we're going to take one side, folding it back over there, and the opposite one, I want you to do the same thing. So taking that flap and pushing it the other direction. So now it's looking like a windmill. Right, we're going to flip it into a different position. So take your piece, and at the back, I'm going to hold the back and I'm going to just bring it up like that. Now, I can't really see the antibody appearing, so I've got it the wrong way round. So I'm going to bring it now to the other side. So there's two positions, you've got two diagonals. Again, I'm going to flip it, and can you see an antibody picture has now appeared? That's now correct. There we go. So one direction won't work and the other will. Looking like this, it looks a bit like a vase. I'm going to take the top corner and fold it down just to give it a little bit more of a rounded end, like so. And I'm going to do that with the other one. And the same with this, just rounding off a bit really. And the other side. There we go. But these bits are kind of a bit loose, not looking good. So I'm going to simply open it up and then tuck this inwards. Get rid of that so no one will know. That's it. Same thing on the other side. Opening that up and then pushing that in to get rid of it. There we go. And same thing at the bottom too. Opening it up and pushing it in. And there. Now you could, if you wanted, add some extra tucks at the top of the arms. So it's the top of the arms that would actually stick to the virus. So at the moment, it would just kind of fall through, but you can make an extra little pocket. If you open up, you can fold that upwards and make a little extra pocket. And there you go. You've got your very own antibody piece of origami. I hope you'll enjoy that. Thank you.